This lesson right here is called Operations and Composition. So we'll talk about composition at the end. Let's just talk about the operations right now. Okay? And it's not a doctor operation, it's a mathematical operation. You've seen this f of x stuff over and over again. It's just like y equals something. All right, but if you're going to have two different equations, instead of saying y equals something and then y equals something else, they both may not equal y, they may equal something different. So well, anyway, let's just say this. So f of x is 9x minus 8, and then they say g of x, which is a different function, is 7x minus 7. All right, so there's your two functions right here. And this is what they're going to ask you to do. And it's actually, I think, pretty straightforward. They're going to ask you to either add, subtract, multiply, or divide these functions. And how do they show that? Instead of saying, f of x plus g of x, instead of saying that, they just say this. They just say f plus g. All right, so if it says find f plus g, it means what? It means take the f function and the g function and do what to those two? Add them together. All right, and watch how easy that is. Now, you're not really solving for x or anything here. All you're doing is just adding these functions together. And there are times in other courses, science courses and stuff, where you have to add things together. And that's what we're doing right here. So it's just 9x minus 8 plus g, which is what? 7x minus 7. You just add them together and you get final answer. You're not really solving for x here. You're just adding two functions together. All right, so 9 and 7 is 16x. And this is what? Negative 8, negative 7, which is negative 15. And that's your answer right there. So that's what the function f plus g is. Very, very simple. The only part that might be a little bit tricky is if they told you to find, let's say, f minus. Let's get a different color here. What if they said find f minus g? You set it up the same exact way, but there's one little trick to this that you have to understand. It says minus, and then you're subtracting this whole function. So what are you going to have to do to that 7x minus 7?
Negative.
Put it in what? Parentheses, okay? We've talked about that, it seems like 100 times this year, haven't we? Okay, when you subtract a sum like that, that has to be in parentheses. And what do you have to do to that negative right there? Distribute, right. And that's the part that a lot of people forget. I bring it to your attention all the time. I even tell you that many, many people forget to do that, hoping that you won't forget it. All right, so we got 9x minus 8. Only this negative is out in front of this parentheses. Only the negative is being distributed. So it's still 9x minus 8, but now it's minus 7x, and that's plus 7. Okay? Now we can add them together. 9x minus 7x is 2x, and negative 8 plus 7 is negative 1, and that's what f minus g would be. All right, that's pretty easy, isn't it? You could, let's stick with the same two functions. You could also do what? We added, we subtracted, we could also what? Multiply. So this is what it would be. You see this f and g right next to each other without anything in between? What do you think that means you're going to do? It means you're going to multiply them together. So it means you take your f function, which is 9x minus 8, and you take your g function, which is 7x minus 7, and you multiply them together. Notice I put them both in parentheses, didn't I? Because when I multiply them, all right, I've got to have them both in parentheses. Now this math is a little bit more challenging than what we did earlier. That was baby stuff we did earlier. But what are we going to have to do here?
FOIL.
Yeah, FOIL, which is the same thing as distributive property, right? So let's just do that. So 9 times 7 is, what's that, 63? And then x squared. And then the outside would be another 63, but it's only x, isn't it? All right, then the inside would be negative. 8 sevens are 56. X, and then the last would be negative times negative, which is positive 8 times 7, which is 56. Add your like terms together, so this would be 63x squared. What's that going to be? That's going to be 119. Did I do that right? Right? 6 and 3 is 9. 6 and 5 is 11, so 119x. Yep. And then plus 56. And that's what it would be right there. So the arithmetic was a little more challenging, but that's what you would do. Again, you're not solving for x or anything, are you? All right, so it's just a matter of learning how to add and subtract. We did that at the beginning of the year, just add and subtract different different polynomials, that kind of stuff. Does that make sense on the notation? Pretty easy, isn't it? What would division look like? They would say this. Now, I'm not going to do this division because I don't think it's going to come out real nice or anything. But what if they said division? It would be F, and then they put a little slash G. Right? You've seen that for division, right? So it just means F divided by G. And really, the only thing you could do would be this. It would be 9x minus 8 over 7x minus 7. Because that really doesn't simplify. You can't really divide those two. So I would just leave it like that. There was no work on that one, was there? Okay. Now sometimes, depending on your functions, you may actually be able to simplify it and actually divide things together. But in this case, you really can't divide, so you would just leave it like that. Okay? So we did addition, subtraction, multiplication, and division. Now there's one other thing. I said the name of this was operations, which we just did. Those are our 4 major operations. And we're going to do a thing called composition. That's a little bit different. So let's start with a clean slate here. Go to different color. And let's do a thing called a composition. Let me just write that word down. Composition. You may have done this in Algebra 2. Okay, this is something that they teach in Algebra 2. And it looks like this. I'm just going to show you a general thing. They put a little circle. You ever see this? Looks like fog. But we don't say fog. We just say F. This little circle means composition. So we say F composition G of X. Does anybody remember seeing that in Algebra 2? Do you remember seeing it? Okay. So it's F composition G of X. What does that mean? What does that tell you to do? Well, let me show you. It means this. It doesn't mean to take F times G. It means to take F of G of X. Does that look familiar at all from Algebra 2? Yeah. If it doesn't, that's okay, because we'll just do it from scratch here. Let me find a couple nice easy functions to deal with. I'm trying to look in the book here. The one in the example, I want one just a little bit easier. Let me just see. Sorry for... Okay, here's one. Okay, so that's basically your definition of a composition. And you're like, okay, that doesn't help me at all. All right, but once we do the example, I think it might make a little bit more sense. Let's do this. I'm going to give you a couple functions. I'm going to give you an f function, and I'm going to give you a g function. Right? Because we have f and g's right here. So my f function is negative 6x plus 9. I'm taking this straight from the book. There we go. All right? And what they're going to ask you to do is they're going to ask you to find, yep, they use the word find, f composition g of x. Yep. You say, what in the world? Well, again, what does this mean? What is this? It looks like fog, but it's not. It's composition. And that means take f of g of x. So here's what we're doing. We're taking the g function. We're taking the g function and we're putting it into, what do you think? The f function. Because we're taking the function of g of x. It's kind of like we're taking this and we're putting it into the f function. So look at this. Look, there's the f and there's your g. I'm taking this, and what am I doing to that? I'm putting that into the f function. Where do you think I'm going to put it into? In wherever the x is, okay? So I'm taking this whole thing, and I'm putting it into that x right there. Okay? So I'm taking this, I'm sticking it into here. That's what f of g of x is. Does that make sense? Okay, so I'm taking the g function, I'm putting it into the f function. So if I'm going to rewrite this, let's do some yellow. So if I'm going to take this thing right here, it's going to be, instead of negative 6x, what's it going to be? It's going to be negative 6 times whatever we're substituting, right? It's just basically substitution, right? It's going to be 5x plus 7. See, I'm taking this thing right here, this g function, and I'm substituting it in wherever I see an x in the f function. right? So it says negative 6 times whatever you're putting into there. So it's negative 6 times 5x plus 7. But then you continue the rest of the function. What's the rest of the function? Plus 9. And now you just simplify that, and that's your answer. Okay? We simplify that by distributing. So that's negative 30x minus, what's that, 42, plus 9. Simplify that one more time. It's negative 30x. What's that? Negative 33. Is that right? 33 and 9 is 42. Yep, that's right. And there you go. So that's what the composition would be. All right, that's what F composition G of X is. Again, what did we do? I always like to write it like this. This makes a little more sense to me than what this thing does. And so that means you're going to take the G function and you're going to put it in wherever the X is to the F function. So I'm taking this G function and I'm putting it in right there. I'm substituting this in for this. And then you just simplify it out. Now, they could ask you to write it the other way. Watch this. Let's go green. They could ask you to find, instead of F composition G, what do you think that?
G composition
Very
F.
good. We could find G composition F. Does that mean it's the same exact thing? No. So watch what we're going to do. What's that equal to? It's equal to G of F of X. So we're gonna take, stick with the blue here. We're gonna take the F function this time and put it into the what? Into the G function. All right. So this time we're gonna take. Let's do this in a different color. What haven't I used yet? It's red, orange. You like the orange? Okay. So this time we're gonna take the F function, right, and put it in where? For the X of the G function. Okay? So instead of writing 5x plus 7, we're going to write 5 times whatever this thing is, and then plus 7. See the difference? All right, so let's keep this green since we started off with green. So what are we going to get? Again, what are we doing? We're taking the F and putting it into the G. So we're writing out the G function, but instead of x, we're going to put in what we've replaced it. So it's going to be a 5 to start off with. And then what did we replace this x with? This whole thing right here, negative 6x plus 9. So I'm going to put a negative 6x plus 9. See, it's just a substitution, isn't it? We just substituted this everything from this f function into the x for this g function. So there's my negative 5x, right, with the substitute in there. And then you got to finish it off, put the plus 7 at the end. And now we just simplify this thing right here. So it's negative 30x plus 45 plus 7. And what's this going to be? Negative 30x, and that's, what, 52 plus 52. And there it is. So that's your F composition G. That's your G composition F. What do you think of that? You do get it now? Good. That's what I like to hear. See? That makes my day when I hear that. Doesn't take much to make my day, but that definitely did, because... Yeah. Let me find. I think they give you something else. Maybe not. Oh yeah, they do. Let's do this. This is the example. I want to do that one first, then I'm going to do this one. We'll finish with this, okay? You got two more functions. You got an f function, which is 2x minus 1. This is still composition, but it's just a little bit different. G of x is 4 over x minus 1. All right, and here's what they say to find. This is a little bit different than what we did before. This says find f composition G, not of x this time. Watch, they actually put a number in there of 2. All right, what in the world does that mean? Well, we write this. I don't like this 0 there, this little O or whatever it is, f composition G. I like to write it like this. I like to write it f of G of what? 2. Again, what does this mean? We got to understand this whole terminology here. We're taking the G of 2 and we're putting it where? Into the F. So what I got to do is I got to figure out what G of 2 is. let's come over here and find g of 2. What does that mean, g of 2? Just means we're going to put the 2 in for the x. That's all. Okay? So let's see what we get. We get 4 over what? 2 minus 1. And what is that? What's 4 over 2 minus 1? 4 over 1, which is just 4, isn't it? So that's our g of 2, isn't it? So our g of 2, let's write it real nice, g of 2 is equal to 4. So what is this thing, what does this composition tell me that I'm going to do? G of 2 actually comes out to be the number 4, right? And I'm just going to put a 4 into the f function. Do you see that? So I take whatever I get for this, and I plug it into the f function. Here's my f function right here. So I'm taking this 4, and where am I putting that? Into the x of my f function. Just sticking it right there.
7.
Yep, so it's 2 times what? 4 minus 1, which is 8 minus 1, which is 7. So this thing right there is just equal to 7. Okay, so we did compositions. We did 2 of them this time. This time, they instead of putting f composition g of x, they actually stick a number in there, which actually kind of makes it a little bit easier, I think, don't you? Yeah. So what do? We do the g of 2 first. All right, since it's f of g of 2, we do the g of 2 first, stick a 2 in for the x in the g function, get an answer. Then we're going to take that answer, whatever that g of 2 is, and we're going to put it in to the f function. All right, we stick it in right there where the x is, figure that out, and there's my f of g of 2. You could have done it the other way. You could have said, they could have said find g composition f of 2. What does that mean? It means we go g of f of 2. So what are we going to do first here? We're going to do the f of 2 first. So you come up to the f function, and you're just going to put a 2 in for that. So what is that? It's 2 times 2 minus 1. 4 minus 1 is 3. So f of 2 is actually the number 3. So what are we going to do with that number 3? We're going to take that 3 and put it into what? The g function. So here's the g function right there. So I take 3 and I plug it in for that x right there. So what's that going to give me? 4 over 3 minus 1, which is 4 over 2, which is 2. Alright? So that whole thing right there is just equal to 2. So you could go both ways, couldn't you? Just depends which number you're putting in first, and then you're going to put it into the other function. Does that make any sense at all? All right. It looks like all these, yeah, all the ones that are actually composition. Oh, actually, you know what? Oh, my goodness. Why didn't I do that? Oh, maybe that's on part B. Maybe I was only supposed to do composition for the part B. That's okay. I'm going to give you a worksheet on this, but it's actually not the composition stuff. It's actually just the add, subtract, multiply, and divide. So I went a little ahead. Oh, you know what? You know what I didn't do here? What if I asked you to do this? Watch. What if I said find f minus g of 3? Remember my f and g functions? So watch this. What does this mean? It means I'm going to go f of 3 minus g of 3. So what do? Stick a 3 in right there, stick a 3 in right there, get an answer for both of them, subtract them, and I'm done. You see that? All right, that's pretty easy. Let me give you a worksheet before you leave.